Hi folks, Bill Steele here with 3DChameleon, and in this quick little video I'm going to walk through two sections. The first one is the installation of the 3DChameleon on a direct drive machine. This particular machine is the Anycubic Mega Zero version 2. Mega Zero 1, it doesn't make any difference. They both use the exact same extruder. And in this case what they have is a direct drive, a BMG style in a Bowden configuration, but it could also be a direct drive. There's really no difference from the perspective of this type of an extruder from our standpoint. I have the Chameleon mounted up here on top, and I have the electronics mounted back here on the side. You'll notice that this machine is kind of reversed from the Creality Ender style machine. It's basically a mirror image. So we basically mirror image the install. With the difference being that instead of having the Chameleon mounted in the stock extruder's location, we've left the stock extruder in place, and instead of connecting the Y adapter to the hot end, we've connected the Y adapter to feed into the BMG. And we'll take a look at that in a little bit more detail here. I have this switch in the exact same location as before. Interestingly enough, even though they've reversed the machine, they've actually left the homing position the same as the Ender 3, so we can continue to use the switch on the right side of the printer here as opposed to the left side. They actually have a homing switch on their end, on their hot end, instead of over on the side here to allow for that. So we've installed this. Now the interesting thing about this install is that we are not tying into any of the stock electronics, the stock extruder, the stock motor. It's all left identical to the way it was. In fact, one of the really neat things about this install is that by removing one screw holding the electronics on, one screw holding the switch on, and two zip ties up here at the top, you can completely remove this and install it on any other printer. So for example, maybe you want to use one 3DChameleon on several different machines. It's quite easy to do that. To disconnect the Y adapter, you're just going to unconnect the PTFE tube. Again, one screw there, and two zip ties holding the extruder on, and the entire thing comes off. This is actually going to be a really cool install for a lot of people. It's going to be very easy, and we are actually going to start producing here shortly a completely built version of this with this installation in mind. So you will buy the kit. Actually, you will buy the 3DChameleon, not as a kit like it is now, but it will be fully assembled, fully tested. You will take it out of the box. You can mount it to your machine, or you can even just leave it on the table, mounted to a spool holder, for example. Repcord sells their rep boxes that will mount to their boxes, for as an example. Mount a switch, plug in the PTFE tube input into your stock extruder, and you'll be good to go. That's coming out in the future here, but we are doing that. That's our next product. So we also have, in this case, the generic 80-20 aluminum extrusion mount, which simply bolts to the front of the Chameleon and zip ties to the printer itself. We have the two cables, both going into our electronics. You'll notice that with this, we have to have two different cables. We're actually using the extruder function of our Chameleon box to act as a drive to load and unload your extruder. And I'll show you that here in a second. But let's go ahead and take a quick look at this machine. Let me go ahead and rotate it around so you can see the install. So here I have the Chameleon mounted up here with the blue portion as a printed adapter. And then that's just zip tied to the top here. We have the PTFE tubes coming out into the Y adapter, and the Y adapter is literally just plugged right directly into the BMG. In fact, this BMG style extruder comes just exactly like that from the factory. It has this PTFE tube coming in to allow you to this, and all we're doing is we're connecting the Y adapter directly to that. So here, let me pull the Y out. Actually, we have it's active, so let me change that one position. That way we can retract that. We just take that and connect it just like that. And that is the connection. That's all there's needed to connect that. The switch is hard mounted. In this case, it's mounted to the 80/20 frame here using a single screw behind the switch. So if you take this screw out, then there's another screw that has the T-nut holding it in place. This is actually triggered at a point which is at the very end of the travel. Again, that's the classic way we install it there. As far over as the extruder will go, that's where we mount the switch. And then at the top here, like I said, we have the Chameleon just zip tied up here. There's 2 zip ties holding it in place. If I cut those 2 zip ties, this would just lift right off. This blue printed piece here is something that you will print for your machine. We have a generic 80/20 and a generic 80/40 version of it. The 80/20 or the 80/40 version will also work on Prusa Mark III machines, for example. Their aluminum, their frame, whether it's aluminum or steel, it'll mount right to that. And that's all there is. So I forgot to point out the electronics are installed right back here. So we have them plugged in. You can actually mount them pretty much anywhere you want to, but I found that's a nice convenient location. So let's go ahead and walk through the next part of the video, the software. I'm going to go ahead and load up the software on the computer, and I'll walk you through what the BMG configuration looks like for this machine. So to start off with, to download the slicer configuration for this particular machine, you can actually go out to YouTube and search for 3DChameleon Mark II Prusa Slicer, and that will bring up the video for using the Mark II with the Prusa Slicer or Prusa Mini, either one here. So if we open this up and we scroll down into the description, you will see that we have a beta for the Prusa Slicer for the Anycubic Mega Zero with the BMG Clone. That's the machine that you see here. You just click this link and that'll download this BMG test1.3mf file. And by downloading that, that'll open it up. You can save it from there. And then in Prusa Slicer, we simply go and open that file up. So let me show you that. We'll just clear this all out here and do a file open. And then there's the file. So we open that. And that's this file here. And you'll see that we have a printer called the 3DChameleon Mark II on the Mega Zero BMG. That's our file there. And it looks like it's just one chip, but in reality it's actually 4 different color chips. So if I hit slice now, you'll see that there's actually 4 different colors in that. Now, again, I haven't optimized the size of this or anything like that. The idea here is that we're just showing the color changing capability of this. I've changed the colors to match what I actually have loaded in the printer. And if you want to change the color, again, this is nothing new here. You can simply click on that and change the color to whatever you want. And you'll see that that updates in the model. But let's go back to the original. So that's how you change the colors. Now, when you open this file up, it's going to come up and tell you that you have based off of the file name. And I always just go ahead and save it and then edit this. Save the name so that it matches what it is you want locally on your machine. And that way you can save it that way. So here you can see I've created a 0.3 millimeter file, and I've also created a 0.2 millimeter file. In the one that you download, I believe there's only the 0.2 millimeter. But the only change I made there was to change this to 0.3. Okay, so if I slice this, there you can see we have the file. Now, what is it exactly that we're doing here? By the way, if you watch the video, we talk about having the output option for doing the reverse drive. In fact, you see that's here, this download the reverse drive post processor. That is absolutely not needed for a direct drive configuration. When we're talking about direct drive, we're talking about loading or unloading the existing machine. And in that case, since you're only using the stock extruder, the printer is already set up to print to that stock extruder. So on the direct drive, you don't actually need the reverse drive Python script, which makes it a little bit easier to install. What do we get when we actually change the when we download this profile? What is it that we're actually doing? Well, really, the only configuration change that we're making to your machine is that we're setting it to have a number of extruders, in this case 4, and you can go up to 32, I believe, in Prusa Slicer, which would be increments of 4 with the 3DChameleon. And depending on how you have it configured, there might be other configurations that can get you, for example, like 7 colors or 8 or 12 or whatever. And you can set those however you want, however your machine is set up. But the default configuration is going to be 4 extruders. And we're telling it that it's a single extruder multi-material setup. We also zero out all of the values here. Actually, that should be 0 as well. We zero out all of the values here for the single extruder multi-material setup. And we make sure we turn off this extrude high current fillet. We don't need to change that. As a matter of fact, in this particular configuration, your stock extruder doesn't change. The settings, the only setting that changes, actually no settings change on this particular configuration. If you were using our Bowden tube replacement extruder, then you would change the E steps, and that's literally the only setting on that configuration. But in this configuration, literally nothing changes. Your machine is still your machine. If you have good print quality out of it to start with, you'll continue to have the same print quality out of it to the after you're done here, because all we're doing in this particular scenario is acting as a loader and unloader of your filament. So how do we do that? Well, we do that by going down into the custom GCode, and we simply add this block of code here. This block of code, it's rather complex, but it's actually simple in how it works. So we're going to go ahead and walk through every step of this and how it works and what you need to do to configure it for your machine. So to start off with here, we're just putting some comments in there, and we go ahead and tell it, tell the display, M117 basically sends some text to your LCD display on your printer. In this case, at the very beginning of a tool change, we're going to unload the previous tool. So unloading tool number, whatever it happens to be. The next one is we need to actually set the extruder into what's called absolute positioning instead of relative positioning. With absolute positioning, if I tell it to go to 100 millimeters, it will move the extruder to 100 millimeters. If I then tell it to go 90 to 95 millimeters, it will move backwards 5 to get to 95 millimeters. If I likewise told it to move to 105, it will not move forward another 105. It will only move forward 10 from that original 95 position to get to 105. So that's what we're talking about there. That's absolute distances from a 0 point. We then tell the extruder to reset its location to 0. Here we move the print head out of the way. We move it off of your part and over to, in this case, X of 204. This is the left-hand side, or I'm sorry, the right-hand side of the build plate at 204 millimeters. And we move the Y-axis, which is the build plate forward and backward, to the middle at 110. The next thing that we do is we actually rapidly retract the filament into the 1.8 millimeter tube. Now, I will tell you, when you do the install, this is an optional feature. Go ahead and leave this code in there. On some machines, we have a 1.8 millimeter tube that we leave in place, and we retract into that, and that takes care of that. On this particular BMG install, we don't actually have that. We didn't really need that. On some machines, it might be that you replace the last 1 inch of your PTFE tube with a section of the 1.8 millimeter tube that we include in your printer. That will allow the filament to be constricted a little bit down to make it the smallest point possible, smallest diameter possible, if you will. And if that's the case, you're just going to cut off 1 inch of the PTFE tube and remount the end of it just a little bit so that it opens up so that the filament will flow down into it. And then you'll insert the rest of your PTFE tube in top of it. And that takes care of any sizing issues that you might have. We then go ahead and push, after we've pulled this out slowly, this allows us to cool to a particular diameter of the PTFE tube. You'll notice that we move very slowly doing that. We then very rapidly ram it back into the tip, and we then retract it again. Again, we then cycle back and forth, ramming it in and out of the tip. What we're doing here is we are eliminating any blobs that are on the end of the tip by ramming them and jamming them into the end of the melted. We take the tip of the filament and jam it into the end of the melted filament that's still in the nozzle. We then can pull that out. Once that's done, we then retract it again, only this time very slowly, very, very slowly, 100 millimeters per minute. We retract it out. Then we go ahead and, in this case, this machine has a fan on the right-hand side that will interfere with where we place the switch. So we want to shut that fan off so that the fan doesn't hit the switch while it's still running. So we turn the fan off. We then, and this is going to be important and unique to your particular machine, we back out the filament, in this case a total of 380 millimeters. Now you'll notice that what we're doing is we're setting the location of the extruder to 0, we're backing it out 100, and then we're setting it to 0 again and backing it out 100. A lot of printers, especially if they're based on Marlin, will have a limit to how far you can actually move the extruder in one single command. And that limit is 100 millimeters. If you go over that limit, then it won't run that move at all. And you'll get what's called an unsafe extruder motion error. And it will simply skip that motion or that move. And that's not what we want. We want to make sure we're putting it in the right location. So what I'm doing here is I have 3 times where I'm moving it out 100 millimeters. That moves it out a total of 300 millimeters. And then we move it out an additional 80 millimeters. And the idea here is this last 80 millimeters is enough to pull it out of your extruder plus a little bit extra. The idea here is that you're going to have your printer force the filament out of its own extruder to the very beginning of it. Once it's out, the extruder no longer has the filament. At that point, the 3DChameleon can grab the filament and pull it out the rest of the way. But we want to make sure that you adjust this 80 value here to pull it out far enough so that it's out of the way of the extruder. And again, you're going to have some number of these, depending on how long your PTFE tube is, between your extruder and your hot end. In some cases, you might not need this value at all. For example, if you're using a direct drive machine like on the Prusa Mark III, you only need this one value here. It's enough to back it out all the way without you having to have these other 3 loops in there. These just add 100 millimeters each time. And of course, since the maximum is 100, the last one is going to be tunable to whatever value you need to completely remove the filament out. Once the filament has been removed from the BMG extruder in this case, we then go over and press the button. Now, in this case, because we're using the direct drive scenario, our machine has pressed the button to unlock the filament by just a short 1/4 pulse. And when it does that, it moves to the next extruder. So say, for example, you were printing on extruder number 1. The 3DChameleon is actually locked onto extruder number 2. So what we do here is we actually press the button 3 times. By pressing it 3 times, we're going to get back to the extruder that we were actually printing from. So let's say you were on extruder 2. If you press it 3 times, extruder 2 goes to 3, goes to 4, which then goes back to 1. So that's how you get back to you simply press the button 3 times and that will get you back to the active extruder. So that's what this block of code does. There's 3 similar blocks of code, and let's look in the details of exactly what each one does. The first line moves to the button, but it doesn't press the button. It's holds short. In this case, I say 1 millimeter, but in reality, I have coded 4 millimeters. So it's moving 4 millimeters short of actually pressing the button. It then moves over and actually presses the button, which is at location 212 millimeters on the x-axis. That's why we have x212. If your button was on the front, it would be on the y-axis. If it was on the top, it would be on the z-axis. In this case, we've located it on the x-axis, the right side. We then wait for 0.3 seconds. It takes a 1/4 second pulse to trigger the 3DChameleon to change to the next extruder. So we simply give it something greater than 1/4 second, and 300 milliseconds is enough. We then move the extruder back off of the button. So we went over, pressed it, waited for 1/3 second, and then unpressed it. And it takes a little bit of time for the 3DChameleon to move to the next color. Now, I just generically put in 2 seconds. You can adjust this to whatever value matches your machine. 2 seconds is a good time. We then repeat that 2 more times, the exact same code. That's what moves it to the next, that's what moves it back to the active extruder. Once we've done that, now we're going to switch modes in the 3D Chameleon, and now we're going to press the button again, but this time we're going to be pressing it for 3 or 5 seconds, depending on which color is loaded. So which is the active extruder? If you are at 0 or 1, pressing it for 3 seconds triggers the mode where you can advance the extruder. If you are on extruder 2 or 2 or 3, if you're on extruder 2 or 3, you need to press it for 5 seconds. So what we do is we move the extruder over to just short of the button. We then press the button. We then use that same pause command, but in this point, we're actually pausing for 3,000 milliseconds, which is 3 seconds. But if we are on the last 2 extruders, we go ahead and add an additional 2 seconds on top of that. So that gets us our 3-second or our 5-second pause. We then move off. Now what this just did is that told the 3D Chameleon which direction we want to spin the motor. Forward or reverse. In this case, this is going to be forward. This is going to be reverse. We're going to be unloading the extruder. And the idea here is that by unloading the extruder with a 5-second pulse or a 3-second pulse, the next time we press the button, the extruder motor is going to start running. And I'm talking about the extruder motor on the 3D Chameleon, not the one that's on the printer. The next time we press the button, that motor will just blindly start turning for as long as I'm holding the button down. So the way we do that is we then move back over to the button, we press it again, and we wait. In this case, I've timed it for 7 seconds. All I have to do is hold it for 7 seconds, and that will back out the filament far enough that it clears the Y adapter. We then move off of the button. If your Y adapter and the spacing between your Y adapter and your printer's extruder is shorter, you can make this time smaller. If it's farther, you can make this time larger. So for example, I had it at 8 seconds originally, but right now I've been playing with it at 7 seconds, and that seems to work okay. So here, this is a second pulse, which runs the 3D Chameleon to pull the filament out of the machine for 7 seconds. Once it's pulled it out for 7 seconds, it now can go into loading the next color. So in this case, it displays a text message to the LCD that we're going to load it. We then go and always, regardless of where we're at, we always reset it back to extruder 0 in this case. So technically, there's another way of doing this that makes it a little bit more silent, and we will be publishing an update to this code that will show you that. Basically, what happens is with the later models of the 3D Chameleon, every time you press for 1/4 of a second, it always advances. So if we knew on the previous extruder that we were on extruder 3 and we wanted to go to extruder 2, we would simply advance it 1/4, 1/4, 1/4, and 1/4. And that makes it, or 3 times, that would make it advance forward 3 times. That is actually a lot quieter than this method. This method actually causes the machine to home, which kind of does a little grinding. If you're already on extruder 1 and you try to home to extruder 1, for example, it might grind for a few seconds, and some people might not like that. So wait for our other code. But this will work just fine until then. So what we're talking about here is, again, we're going to press the button, but in this case, to get it to go back to the home position, in other words, the first extruder, in this case we call it 0, we press it for 1.3 seconds. Now normally we only need a 1-second pulse, but 1.3 is longer than that, so that should work. That's just a nice, if I said 1 second here, it would still work, but it's only 1/3 of a second more. So this just ensures that we've exceeded that 1 second value. So we press the button for 1.3 seconds, we then let off the button, and then we wait for the homing routine to occur. So in this case, we're waiting for 4 seconds. By the way, I might point out, you'll see that there's 2 G4 commands that take different parameters. What are they? Well, this first one here is G4 with a P parameter. The P indicates milliseconds. We're going to wait 1,300 milliseconds. The G4 command with the S, think of S as in seconds. So this is going to wait 3 seconds. So if we wanted to wait 3.5 seconds, we would need to do a P 3,500, right? 3.5 seconds is 3,500 milliseconds. So this is pressing it for 1.3 seconds and then letting off, and it's waiting for the 3D Chameleon to do its job for 3 seconds. Once it's done, we then get into the logic of figuring out, okay, we know we're extruder 0, but what if I want to go to extruder 1, 2, or 3? Well, in that case, each time we want to go up an extruder, that's if we are, if we are at 0 and we ask for 1, then we're going to press it at least 1 time. If we're going to ask for 2, we're going to press it at least 2 times. And if we ask for something greater than 2, then we're going to press it at least 3 times. And that's what these are. These are the exact same block of code that we did before, where we go and press the button for 300 milliseconds and then back off and then wait for that to happen. So that's all this code does. Once that's done, you are now on your new selected extruder, which is the next extruder parameter that you see here. We then go ahead and just wait 1 extra second just to make sure that it's homed and gotten to the right position. Once we've done that, we can then go ahead and load the filament. Now remember before where we did the 3 or 5 second pulse? Well, now we're going to do a 3 or 5 second pulse, but it's the reverse. We're going to tell the motor to go in the opposite direction. So if we want to go forward on extruder 0, for example, that's a 3 second pulse. If we want to go backwards on extruder 0, it's a 5 second pulse. Likewise, the same thing for extruder 1 and the reverse of the other 2. Remember, we only have one motor. We're just commanding that motor which direction to turn. So we're using the logic of the slicer to calculate which direction it should be turning. So in this case, again, it's a 3 second or a 5 second pulse, and that puts it into the mode where it allows us the next button press to load or unload. Now in the previous one, I unloaded for 7 seconds, but here we're going to reload, again, same button press, but we're going to reload for 7,500 milliseconds. Now why are we doing that? Well, I want the nozzle, I want the tip of the filament to run into the extruder. That's why we're pressing it. And while that's happening, after this pause, I then immediately turn the extruder on before I have let off the button. And the reason being is that I want the extruder to grab the filament while I'm still pressing the button and loading it in. And that's going to force it past the drive gears in the BMG and into the tube. Once I've done that, I stop moving the extruder. I set it to 0. I let off the button of the extruder, and then I press it one more time to move it to the next color. So this is moving the 3D Chameleon to the next color, which lets go of the previous color. So we can only have one active at a time. And when one is active, all of the others are free to move, in other words, to be pulled in and out of the 3D Chameleon by hand, or in this case, by the extruder. So what happens is we've now loaded it a few millimeters, in this case about 2 inches, into the past the extruder, the 3D printer's extruder, right? It's now loaded into that machine. We can now let go of it and allow the printer to take care of the rest. So we do exactly that. We press it for 1/4 of a second, we wait for that to happen, and now once that's done, we can now move off of the button, move away from it, we can turn the fan on, and then just like we unloaded before, now we're going to reload the filament. We're going to reload those 300 loops that we did before, and you'll notice that I'm only loading at 50 this time. This is an interesting one. You say, but Bill, you unloaded at 80. Well, if you remember, 80 was to make sure we got it passed out of the extruder. We didn't want to go too far, right? Actually, we wanted to go too far. We wanted to go, because it can't push it any farther past that. But I measured this machine, and it's only 345 millimeters from the extruder drive gear to the nozzle. So in this case, we're actually loading it a little bit extra. Now, that's a problem on some machines. It's going to create a blob. So this value here is the one that you're going to tune to adjust to that. And in fact, on this particular machine, I found that 45 is the optimal value here. By loading it to 45 millimeters, 345, that's moved the filament right to the tip of the nozzle. And then once we're done with that, we then we're done with our tool change. It's now loaded to the proper position, and the normal slicing can take over and start printing the rest of it. So we then go ahead and return the extruder back to its relative distancing, and we go ahead and set the command telling everybody in the world that the 3DChameleon is now changed to the new color. This value right here is the one that you're going to tune so that it doesn't blob when it reloads the filament. Now, every once in a while, you're going to get a minor blob because there's going to be some variation in the system that's going to cause it to do a little bit too much or a little bit too little. But that's where we actually have our purge block in Prusa. That's going to hopefully occur in here. If it is not occurring in here and you start to see, filament not being printed while it's starting, that's possibly because this value here is too low. So just increase this value, and you should be good to go there. So let's go ahead and do a quick review of the portions that you're going to tune for your particular machine. Pretty much all of the unloading and loading routines are not going to change. You're going to change the holding position here. And that's basically where do you want the nozzle to unload. I always move it off the part. I don't want if it's going to dribble or drool or have any filament escape the nozzle while we're not doing anything. I don't want it to be on top of the part. So I'll always move this to, as a matter of fact, if you look over here, I will always move this to over here to the side over here, so that if any drizzling or something occurs, it's on the opposite side of your purge tower than your part. That way, when the machine moves back over across here, it'll drag it across the top, and we'll use this as a cleaning tool to clean the nozzle before it gets to your part. That's a very, very effective way of dealing with that. So the next thing that we're going to tune, you shouldn't have to change any of the tip shaping algorithms. The next portion, though, you're going to tune is the distance that you need to back it out of your extruder. Again, it's in 100 millimeter increments. So let's say you had to back it out 600 millimeters. Well, if that was the case, you were going to have 6 of these 100 millimeter blocks in there, and then you would have your last block that does it however much farther you did it. And like I said, I added an additional 50 millimeters on top of this. The motor turns a little bit extra, but it guarantees that it's unloaded from the extruder. The next thing that you're going to tune, you shouldn't have to tune the buttons here. You might have to tune this value here. This is how far it takes to remove it from your extruder to beyond the Y adapter. So I like to have it about 1 inch above the Y adapter. So in this case, that's about 7 or 8 seconds, somewhere in there. I went ahead and shortened it to 7 seconds. But depending on the distance you have between your drive gears in your extruder and the top of the Y adapter, that could be varied depending on how you have it installed in your machine. So you're going to tune that value there. And then likewise, there's going to be a reloading value that's going to be very similar to that. In this case, I have a 7.5 second load. And that's actually going to push it into the stock extruder. You also might tune this value here. I'm loading it 50 millimeters, but I don't necessarily have to load it that far. You might load it only 25 millimeters, just 1 inch into it, just enough for that that your extruder has grabbed a hold of the filament and that it'll work. Now this is a nice safe value. By the way, you're also going to want to tune this value here. This is the speed at which the extruder loads this. So when I talk about the speed at which the extruder is loading it, we also have to match it up with the speed that the 3DChameleon's extruder is actually pushing the filament. We want them to both push and pull the filament at the same speed. That way they don't fight against each other and you get skips. If you get skips in that arena when you're doing that, you're going to hear the machine kind of complaining. It's going to click. One of the motors is going to stall. And that can actually cause you some issues because you don't exactly know where the filament is. You don't know which one was stronger or weaker. So be careful with that. Tune this value to match the 3DChameleon speed. The 3DChameleon speed isn't that it's not variable. It's a static speed. Loading and unloading are going to run at the exact same speed, and there's no tuning of that. It's just you have that speed. That's what it is. So make sure you tune this value to match that. Basically, what you can do is you can have it load the 3DChameleon, advance the filament, and you could time how long it takes it to go over, say, 100 millimeters, and then you can use that to actually define what the speed of your extruder is. This is going to be very machine dependent, though. I found on this particular machine 2500 is a pretty good speed for that. So the next thing that you're going to tune on your machine is the reload. How far do you reload the filament? Okay, and that's going to be like we talked about before. If I said it was 600, there's going to be 3 of these E100 blocks. And then lastly, how far to get it to the exact tip that you need it. Get the nozzle, the tip of the filament right into the tip of the nozzle, right? And that's where you're going to tune this value. By the way, 45 is an integer. It doesn't have to be. You could do it, some decimal value if you found you want to get into a really nice tweaking of it. I can tell you this right now, this value isn't too important, again, because you have your purge block, but this value right here, if you don't actually match this correctly, then you could actually cause skipping to occur, and if that's the case, you're going to have a lot larger variations in that than a decimal of that millimeter distance there. So I would concentrate on this, getting this right, before you try to tune this too far. Now you can shorten this up. Say, I say 45, it puts it right at the tip. You can make it 44, right? And then it's not going to start printing as it starts doing here, but then it'll eventually catch up. And you can tune that with the size of your purge volumes by just simply adjusting how much purge you actually have between each color. So that's all there is to the 3DChameleon's BMG direct drive code. This is going to be a very, very, very similar set of code for other machines. So for example, the Prusa Mark III simply doesn't have these blocks of code. In fact, I leave them in there. They're just commented out because we don't need to load it beyond more than 100 millimeters. In fact, the entire distance on this particular machine is only about 95 millimeters. So you can tune that to however you want, again. And literally for the Prusa Mini, for example, if you're going to load theirs, you're going to have a larger value. You're going to have a larger value here, okay, to back it out into the BMG style extruder or their Prusa Mini. There is a larger distance, but I believe it's only like 250 total. So you might have, you might miss one of these. But pretty much this code will work for the Prusa Mini. It'll work for the Prusa. In fact, it'll work for any direct drive machine or Bowden machine if you're going to load the Bowden. So for example, maybe you have a Creality under 3 and you want to continue to use the Creality hot end. Now with that one, you do have a slight difference. I showed you at the beginning of the video where I was actually using the BMG's PTFE tube. Well, there is no input PTFE tube on a Creality under 3. So you're going to have to use one of the included PTFE adapters that we include in our kits and adapt a small piece of PTFE tube to that so you can connect the Y adapter. And you'll have to have a 3D printed adapter to do that. Again, same thing. We did something similar to the Prusa. If you go back and look at the original Prusa Mark III version that we did, and you look at our Prusa Mark III video, you'll see that we have a small piece of PTFE tube into one of our PTFE connectors into a printed adapter, so that allows it to load and unload. We also have one for example, the FlashForge and MakerBot replicator style machines. That includes Dremels and everybody else like that. QIDI, GD Tech, or however you say that. Those types of machines, they're all going to use this exact configuration. Only they will have a very short distance here since they don't have a tube between their extruder and their hot end. They just have a very short distance there. So you could tune that to a small distance. So that hopefully gives you an idea of how the BMG style, or I should say the direct drive, using the Chameleon to load a direct extruder printer without having to use the reverse drive or anything else like that. So the nice thing about this, like I said, is you can define a custom configuration for each machine. You can pull that 3DChameleon off of machine A and easily install it on machine B and only have a software change between them that's tailored to that particular machine. So you can use the same 3DChameleon on many different machines that way. It's a really nice install. So thanks for watching, and if you have any questions, as always, feel free to email me at bill@3dchameleon.com, and have fun.